Hey everyone, and welcome to today's rapid revision. Okay, let's just dive right into it. We are tackling 12th chemistry today, focusing specifically on Unit 8 ionic equilibrium. So if you've been looking for a crystal clear, direct way to lock in these concepts right before your exams, well, you're exactly where you need to be. We're going to strip away all the fluff and get straight to the core material. To do that, we are grounding ourselves in a super trusted source. Let's pull this up in a full cinematic view. What you're seeing is our foundational text, the 2 guide, specifically page 68 EM. For this explainer, we're mastering section 8.1 and 8.2. Literally everything we cover today comes straight from these crucial pages. Here is our roadmap for the session. First, core acid-base theories, then theoretical limits, conjugate acid-base pairs, a practice analysis, and finally, tomorrow's test. All right, let's transition right into our first major block, core acid-base theories. This is literally the foundation for the whole unit. Let's tackle our target questions, and you'll notice these have popped up in past exams, like August 22, March 20, and June 22 and 24. Target 1, 2. Explain the Lowry-Bronsted acid and base theory. Target 2, 1. What are Lewis acids and bases? Give 2 examples for each. Now may nagiparichegut, radika makika para mukyamana acid-base theory kilvigalapati tiliva pakapolo.
So let's look at the framework itself. Arrhenius concept. Acid yields H plus or H3O plus in aqueous solution. Example, HCl. Base yields OH minus in aqueous solution. Example, NaOH. Lowry-Bronsted concept. Acid, proton H plus donor. Example, HCl. Base, proton H plus acceptor. Example, H2O. Lewis concept. Acid, electron pair acceptor. Example, AlCl3, BF3. Base, electron pair donor. Example, NH3, H2O. இந்த 3 முக்கிய தியரியும் acid base எப்படி வேலை செய்துன்னு வெவ்வேறு வழியில நமக்கு சொல்லுது.
Now, no theory is absolutely perfect, right? And examiners love to test you on the boundaries. Let's examine the theoretical limits. First up, where Arrhenius falls short. This is actually a limitation highlighted in the PY1 May 22 past paper. Error report. Fails to explain the properties of acids and bases in non-aqueous solvents. Cannot explain the basicity of substances that lack a hydroxyl group. Example, NH3. தண்ணி இல்லாத இடத்துலையும் OH group இல்லாத பொருட்களையும் இந்த Arrhenius theory சரியா விளக்கல.
Similarly, the proton theory has its boundaries too. This concept cannot explain how substances that do not donate protons, such as BF3 and AlCl3, still act as acids. புரோட்டானை கொடுக்காத சில பொருட்களும் எப்படி ஆசிடா வேலை செய்யுதுன்னு இந்த தியரியால விளக்க முடியல.
Moving right along, let's shift our focus to an incredibly high-yield topic for your exams, conjugate acid-base pairs. Here's the definition. Chemical species that differ only by a single proton H+. Examples, HCl and Cl-, H2O and H3O+. This exact foundation was tested as PY1 AMAR 23.
ஒரு புரோட்டான் அளவில் மட்டும் மாறுபடுற 2 பொருட்கள் தான் கான்ஜுகேட் ஆசிட் பேஸ் பேர்.
Okay, theory is great and all, but application is everything. Let's jump into the practice analysis and look at some actual chemical equations.
Here is our first reaction. HSAQ plus HF, equilibrium F minus AQ plus H2SAQ. Notice the pairs, base 2, acid 1, and base 1, acid 2. Acid HF-லிருந்து ஒரு proton போனதும் அது conjugate base F- ஆகுது.
This next reaction, straight from the June 20 paper, perfectly illustrates this point. HPO4 2- plus SO3 2- equilibrium PO4 3- plus HSO3-. Again, notice the pairs, acid 2, base 1, base 2, acid 1. In the reaction line, HPO4 2- protono கொடுத்து conjugate base PO4 3- ஆகுது. Let's look at the third practice equation. NH4 plus CO3 2- equilibrium NH3 plus HCO3-. The pairs are acid 1, base 2, and base 1, acid 2. Inke NH4 plus acid acealbade or protona korte NH3 amarade. Now let's apply this to a direct question. Q4. Explain the acidity of HClO4 based on the Bronsted-Lowry concept and find its conjugate base. Answer. HClO4 is a proton donor, i.e. an acid. Its conjugate base is ClO4-. HClO4 ஓட protona குடுக்கறதால அது acid, குடுத்ததுக்கு அப்புறம் வர ClO4- தான் அதோட conjugate base. Let's review one simple, absolutely unbreakable rule before we test ourselves. Conjugate base rule. Acids lose a proton, H+, to form their conjugate bases. சுருக்கமா சொல்லணும்னா ஆசிட்ல இருந்து ஒரு H+ போன அப்புறம் வர்றது தான் அதோட கான்ஜுகேட் பேஸ். Alright, time to put everything we've covered to the ultimate test. Welcome to the exam evaluation segment. We're pulling multiple choice questions right out of the TOEIC Guide worksheet sections 8.1 and 8.2 to prep you for tomorrow's test. Let's look at question 5 from the SEP 20 exam. 5. The conjugate bases for the Bronsted acids H2O and HF are respectively A. OH- and H2F+, B. H3O+ and F-, C. OH- and F-, D. H3O+ and H2F+. Option C is the correct answer. H2O learned than the H+ pona, OH-, HF learned the H+ pona, F-, Avanal option C then correct.
Moving to question 19 from May 22. 19. Which of the following can act as both a Lowry-Bronsted acid and base? A. HCl, B. SO42-, C. HPO42-, D. Br-. Option C is the correct answer. HPO42- protona வாங்கவும் செய்யும் கொடுக்கவும் செய்யும் அதனால இது ரெண்டுமாவும் செயல்படும்.
And finally, question 18. 18. H2PO4- is the conjugate base of which of the following? A. PO43-, B. P2O5, C. H3PO4, D. HPO42-. Option C is the correct answer. H3PO4 or H+ அயனிய இழந்தால்தான் அதோட conjugate base H2PO4- உருவாகும். எக்ஸாம்ல எந்த கேள்வி வந்தாலும் இந்த கான்செப்ட்ஸை வச்சு நீங்க ஈஸியா மார்க்ஸ் ஸ்கோர் பண்ணலாம். That wraps up today's explainer. But ask yourself, if they twist the equation tomorrow and hide the proton donor, are you truly ready to spot the conjugate pair? Keep reviewing and absolutely crush that test tomorrow.